Thank you very much indeed, David. It's a great delight to be here. I last gave a talk to the Institute of Ecotechnics about 25 years ago, and I have wonderful memories of that meeting in Aix-en-Provence, and I'm really enjoying this meeting too. Well, my title is Cosmos, Creation, the Culmination of Consciousness, and I should explain that I'm a cosmologist, which means I study the universe. So I'm going to come at this topic from a somewhat different direction than the previous speakers, from a sort of cosmological rather than chemical direction. But I think it's very much related. The plan of my talk, I'm going to start off by talking about the evolving view of the cosmos. And the point about this, you might think, well, what has that got to do with consciousness? Well, what I'm going to try and explain is that actually, rather like Ralph referred to the expansion of consciousness, our evolving view of the universe is essentially an expansion of consciousness. It's, if you like, the ultimate trip, except it takes place over hundreds of years. And then I'm going to talk in particular about the question of how complexity and the consciousness arises in the universe, because that to me is the key point. Something about the evolutionary role of mind and spirituality, and even the possibility that science itself can be extended to accommodate consciousness. Although if I get onto that, I'll be talking in very speculative terms, which most physicists would not like to be associated with. So let me just start off talking about our evolving view of the cosmos. You see, the expansion of science, our scientific knowledge, can really be thought of an expansion of our consciousness to ever larger and smaller scales. So let's first of all talk about that outward journey. Of course, we started off with the geocentric view, where the Earth, man, if you like, is the center of the universe. We all know, of course, that was demolished by Copernicus in 1542. Beautiful picture of Copernicus there. And he, of course, taught us that, in fact, the center of the universe is the sun, and the universe is the solar system. And, of course, the point about this, I should have said that in the previous view, the Earth is at the center, and essentially the planets go around the Earth, but the fixed stars, that is the domain of the divine, okay, can never change. That's an important thing to remember. Well, of course, it wasn't long before we realized that the sun wasn't the center of the universe either. The sun is just one of, as I think Ralph said, 100 billion stars in the universe, in the galaxy. And so by the turn of the 20th century, we realized that actually the universe is the galaxy. Most people did not think there was anything outside the galaxy. And this is a typical galaxy. This is the Andromeda galaxy, our nearby neighbor, like a disk of stars. And so a great issue, though, was whether there was anything outside the galaxies. And up until about the 1920s, nobody knew. At least there was a big controversy about whether anything existed outside the galaxies. But then, due to astronomical developments, more powerful telescopes, it was realized that actually our galaxy is just one of billions of galaxies. In fact, we know there's something like 100 billion galaxies. And that realization came about towards the end of 1929, essentially due to this gentleman here, Edwin Hubble, who measured the distance of galaxies, and he also discovered something really important. He discovered that galaxies are moving away from us with a speed proportional to their distance. And this was the discovery of the expanding universe. And I shouldn't really use equations, but there is one equation, v equals h naught, the velocity is h naught times the distance. That's Hubble's law. And the point is, h naught is a constant, and if you work out what that is, it's roughly 13 billion years, okay? Now, 13 billion years is going to turn out to be the age of the universe. So just it's well to realize that. But actually, the funny thing was that we already knew Einstein's theory of general relativity in 1916 had already actually told us that he could have predicted the universe was expanding. And the way we think of this, we think of having a balloon, and you think of galaxies as being painted onto the balloon. The equations of Einstein tell us that the balloon is space, okay, except the 3 dimensions of space are in that 2-dimensional surface of the balloon. And space is expanding, and that's why the universe is expanding. And incidentally, the person who really appreciated this most was Georges Lemaitre, who was a cosmologist but also a priest. He's sometimes said to be the father of the Big Bang. And at a meeting on science and spirituality at the British Association meeting in 1932, he actually proposed his primeval atom picture, which said that the galaxies are expanding. If you go back into the time in the past, they must all have converged at a Big Bang, which he called the primeval atom. And so that was a very important development. He realized that the universe started. That was the creation of the universe. The first word of my title is creation. Well, this was the creation of the universe. Now, so that was the evidence for the Big Bang. And then there was the discovery that the universe is bathed in this sea of background radiation, which was in the 1960s. And that was the real evidence. That's the relic from the hot early stage of the universe. I loved your picture, Amanda, of the study of the brain, okay, as when it was being stimulated. And this reminds me of that. So maybe this is the brain of the universe being stimulated. But anyway, at this point, then, cosmology has got this, what we might call the cosmocentric view. We've gone from the galactocentric view to the cosmocentric view. The point is, when we look out at the universe, we're looking, as we look to large distances, we're looking back in time. So we're actually looking back, way back to the beginning of the universe. And we can't look further than the distance light has travelled since the Big Bang, which, remember, was 14 billion years ago. So we can't see further than 14 billion light years. And so that's the edge of the universe, and there's the microwave background at the end. Now, you might have thought that was the end of the story, but actually then we discovered about 10 years ago, 1998, we discovered something really odd. We discovered that the universe is not only expanding, but the universe is actually accelerating. It's expanding faster with time. And you would have expected that it would slow down because of gravity. But we think we understand the reason for that. It's because Einstein's equations have what they call a cosmological constant, which is like a repulsion term. And this was a very exciting development. So why is it expanding? Well, it's because we think the universe is filled with what we call dark energy. Well, we don't know what dark energy is. It's like a cosmological constant, but it's essentially the vacuum. So the universe is dominated by this vacuum and, say, the unbearable lightness of nothing. And that's really what 70% of the universe consists of. And actually, cosmologists already had the idea that the early universe might have had this cosmological constant, because in our models of the early universe we have what we call inflation, which said the universe went through this very rapid expansion phase, and that explains various things about the universe. And so I'm going to miss out something. So this is the history of the universe, which I just want to summarize. This obviously isn't a lecture on cosmology, but I just wanted to show this beautiful picture. This summarizes the actual history of the universe, starting in the Big Bang on the left, going through this inflationary phase, and then eventually, after about 1 billion years, galaxies form, and then planets, and then us. And there is that satellite. It's called the WMAP satellite, which took that beautiful picture of the radiation. So that's the summary of the history of our universe. Now, and of course you might say, well, what lies beyond the horizon? Because remember, you can't see past the distance light has travelled since the Big Bang. But the universe doesn't come to an end there, okay? Because it's just like sitting on the top of a boat. You can only see a certain 7 miles or something, but we know the ocean goes on further. And so cosmologists now speculate that this is what the universe might look like. This is the idea that actually our universe is just a tiny part of a multiverse. Now, I've written a book on the multiverse, but I don't want to be plugging a book. I'm saying that because I think it's relevant to this talk. But the point about this, the little part of the universe which we see is that little purple bit. That itself is part of this bubble, which is our universe, if you like. But that universe itself is just one of many, many bubbles. And that's what's called the multiverse theory. Now, of course, I don't know this because we can't see those bubbles. But this is what some of the theories predict. Now, I'm saying all this because, of course, I said in some sense the expansion of consciousness is like the ultimate trip. for those people who undergo chemical expansions of consciousness, your view of reality changes. And I think it's equally true of this perception that comes from developments in cosmology. So if we contemplate the result of this outward journey, this is the same picture actually which Ralph used, except for some reason he's looking on the right instead of the left in this picture. I don't know if the view is different. But the point I want to get across is, first of all, what we call the universe or the cosmos is always growing. We as human beings, including consciousness, have become increasingly insignificant. Okay, we're no longer the center of the universe, and as the universe gets bigger, we get smaller. And also, the heavens have been stripped of their divinity. So we go back to that old Platonic view where the heavens, that was the domain of the divine. There's no space for God anymore. We've looked as far as we can see, and God isn't there, according to this view. That's rather depressing. And here's a famous cartoon. You are in no importance, did you know that? You're only as tiny a speck in an enormous universe, that I might as well go back to sleep. However, I hope you will stay awake. But I mean, this is Stephen Weinberg said, the more the universe seems comprehensible, the more it seems pointless. Now, so that's the outward journey. What about the inward journey to ever smaller scales? Well, of course, we know that in studying the micro world, we've also shattered our view of reality. Just as under chemicals you get a different view of reality, it happens on the inward journey too. We've discovered that matter is made up of atoms, it's mainly empty space and not solid tables. And then we discovered quantum theory, which says that even atoms aren't like solid balls, they're probability waves and things like that. But more important, we discovered that physics is able to unify all the forces of nature. It was really beautiful. We discovered that there was the different forces of nature. There's electricity and electromagnetism. They were merged as part of electromagnetism. There's a weak force involved in radioactive decay, and that's merged with electromagnetism as the electroweak force. There's a strong force, which is merged with the electroweak as part of what's called the grand unification. And then the final challenge is to merge the fourth force, which is gravity. And now all the physicists and some of the brightest brains on the planet are working on this, are interested in the possibility of what we call M theory. Okay? The M theory is meant to be the final unified theory of all of physics, which explains how all of these forces which control the universe fit together. Well, that's great. But then if you think about what's involved in things like M theory, it's really rather weird, completely different from our common sense reality. Just to give you a whiff of this, in superstring theory, you've got these extra dimensions. We're used to 3 dimensions of space, 1 dimension of time, but we've got, in these theories, we've got all these extra dimensions, which are sort of very compactified on such a small scale that you don't see them. This is a beautiful picture. It's on the front of my book. I won't go into what it means, but it's the geometry of these extra dimensions. In M theory itself, you've actually got 7 extra dimensions, so we live in an 11-dimensional world. So the progress of physics sort of goes from 4 dimensions of relativity to 5 dimensions of what's called Kaluza-Klein, and then to the 10 dimensions of superstring, to the 11 dimensions of M theory. Let's hope that's the end. But anyway, so it's an interesting trip. And actually, the current popular picture is the one in which our whole universe is called it's like a brain, a 4-dimensional brain, B-R-A-N-E, in this high-dimensional bulk. And so the history of physics is one of increasing dimensionality. Well, that's a little bit technical, but I just want to try and get across to you that our common sense views of reality have completely changed. It's a brief history of physics, and we're starting with men and women at the bottom, okay? And I'm going to show how as we expand our consciousness to larger and smaller scales, we get this great view of the universe, ever-growing view of the universe. And I'm going to put down here the scale underneath in black, in centimeters. So we see on larger scales, which is going to the right, we see mountains and insects on the left. We then get to see the Earth, and at this point we've got the geocentric view. And then with our microscopes, we're looking to see at amoebas. With telescopes, we're looking to see the sun and then the solar system. And then we're getting to see the They're discovering the forces. There's the force of gravity discovered by Newton. So I'm going through a history of about 300 years now in about 3 minutes. We discovered the electric force and the atoms. We discovered the same electric force which makes the electron go around the atom is what holds solids together. We discovered the galaxy, and we went to the galactocentric view. We then discovered the cosmic expansion I told you about by Hubble. We then discovered the nuclei inside atoms that weaken the strong force, which of course give us nuclear energy and all the blessings and disasters that's involved. Then we have the electroweak force. We also discovered dark matter. I haven't talked about that. And our unified theories gave us particles called WIMPs, which could explain that. The grand unified theory, that could explain where the fluctuations in the microwave background come from. Those little changes of colour, by the way, were temperature fluctuations, which eventually give rise to us in galaxies. And then we discovered the dark energy. That's the microwave background, like Amanda's brain state. And then the vacuum energy, which is associated with these theories. So, and there is the Big Bang. And so this is our picture of the universe, which ends up with the multiverse on the right and the M theory on the left. And so to me, that's a wonderful summary of the triumph of physics and explaining the unity of the universe. And this is the journey. This is the trip, the great trip, as I like to think of it. But, no, it hasn't finished yet. Oh, thank you, yeah. Only the beginning of our trip, yeah. Now, halfway through. But now the thing is this. It's the Big Bang, incidentally, because when you look to the largest of distances, you're looking at the earliest of times when the universe was as small as possible. So that's why the largest is in some sense merged with the smallest. This is the symbol of the Ouroboros swallowing its own snake. So this is a triumph, isn't it? You've got M theory and the multiverse, the Big Bang, but there's something missing. Halfway through my talk, we discovered what's missing, and I'm sure you all know what it is. Mind. This picture seems to have nothing to say about mind and consciousness. And this is really ironic because, of course, in some sense, the culmination of these structures around this are levels of structure and complexity, if you like, which exist in the universe. And down at the midpoint is essentially the brain. Okay, it's people, but they contain brains. And so you can think of brains as the culmination of complexity. That's what the universe seems to, at least as far as we're aware of, has resulted in. And yet, if you ask most physicists, they're not very interested in consciousness. Here are some quotes. John Watson, who was a behaviourist, the time seems to come when psychology must discard all references to consciousness, when it need no longer delude itself into thinking that it's making mental states the objects of observation. Psychologists. Here is Daniel Dennett, philosopher. Consciousness appears to be the last bastion of occult properties, epiphenomena and immeasurable subjective states. In short, the one area of mind best left to philosophers who are welcome to it. Let them make fools of themselves trying to corral the quicksilver of phenomenology into a respectable theory. And yet, that whole picture I've told you is essentially, I've described, is an expansion of consciousness. And yet, however, not all physicists think like that. Some physicists think consciousness is very important. I'm sure you know some of these quotes. James Jeans, no one can deny that mind is the first and most direct thing in our experience. All else is remote inference. Even our picture of physics is ultimately a mental construct. Bears very little resemblance to common sense reality. Eugene Wigner, one of the founders of quantum mechanics, it's not possible to formulate the laws of physics in a fully consistent way without reference to consciousness. John Wheeler, mind and universe are complementary. Bernard Carr, the doctrine that the world is made up of objects whose existence is independent of human consciousness turns out to be in conflict with quantum mechanics. Noam Chomsky, physics must expand to explain mental experiences. Roger Penrose, we need a revolution in physics on the scale of quantum theory and relativity before we can understand mind. So, and put it another way, here was this wonderful theory of everything, but actually it's not. It's only half the world is missing. All that part of the world I experience in my dreams, in my psychedelic experiences, in my mystical states, it's all missing. And so to call that a theory of everything is really very pretentious. And in some sense you might think, well, maybe in some sense I can have a bigger picture which incorporates consciousness. So I would like to say, and many other people would say, that mind is actually a fundamental and not an incidental feature of the universe. It's not a view that all physicists would agree with, but at least some. And there are various clues for this that come from physics itself. One of them is what's called the anthropic principle, the fine-tunings which are unexplained. One is from quantum theory. I think a lot of those quotes were connected with the fact that quantum theory seems to suggest that consciousness plays a role in physics. The other actually comes from the evidence for what's psi. Now, I'm very interested in paranormal phenomena. I'm not going to talk about it here because I'm being filmed, but the fact of the matter is, the fascinating thing about the paranormal is that it shows that mind, consciousness, can directly interact with the physical world. That's what I'm so fascinated in. Actually, I'm just going to focus on the anthropic principle because I'm a cosmologist. Now, I told you about the four forces of nature. Now, they've all got a certain strength, which are called coupling constants. I don't like to use equations, but these are just pure numbers which tell you about the strength of the forces. So the strong force is the largest, number 10. The alpha is 10. The gravitational force, alpha g, is 10 to the minus 40. Now, the great goal of physics is to try and understand where those numbers come from. And it would hope that physics, end theory or whatever, would explain them. But it's not succeeded. We just don't know where those numbers come from. And so will the final theory of everything explain these values? We'd hope so. Some people would hope so, but the answer is no. And yet, the funny thing is, there are strange, mysterious fine-tunings between those constants, which aren't explained by physics, but seem to be necessary in order for us to be here, observing the universe. Let me just give you an example. You only have planets because it turns out that alpha g has to be the 20th power of alpha e. Now, I'm not going into the physics of that. That's a physics prediction. That's true. Alpha e is 10 to the minus 2. It's the 20th power gives you 10 to the minus 40. That's true, and it's needed for us to be here if you want planets. It's not explained. This is star formation in an Eagle Nebula. Supernova, exploding stars, they're necessary because the chemicals which go into us and into LSD ultimately come from stars which explode. And that's because you need the relationship alpha g is alpha w to the fourth, which again is true but not explained. That's a supernova. So these relationships are needed for life but unexplained by physics. To me, that is the indication that something is missing in physics. And in fact, it's called the anthropic principle. I don't like the word anthropic principle because it seems to imply that it's something to do with man. It's nothing to do with man. It's really to do with the evolution of complexity. The amazing thing about the Big Bang is that it allows the evolution of increasing complexity. This is what's called the pyramid of complexity. And as the universe evolves from the Big Bang 14 billion years ago, you start off with things like quarks and gluons, nucleons, and then you get atoms. Eventually you form galaxies and stars, and they give you molecules, biomolecules, you get planets, and then you get cells and organisms. This only arises because of the disequilibrium in the Big Bang, but it only arises because of this amazing fine-tuning. So this pyramid of complexity, which is the basis of everything, only arises because of these unexplained fine-tunings. Now, of course, we're also interested in higher levels of complexity. For example, you could regard the brain, as I said, as the culmination of complexity, but it's consciousness, mind, and spirit. So I like to expand this pyramid to include those. But in some sense, the prior conditions, the conditions for that, are also these fine-tunings. So to me, these fine-tunings are absolutely crucial. And those of you who are interested in Teilhard de Chardin will see a sort of similarity between his ideas of the evolution from, evolution going from a physical level to a mental and spiritual level. So I think it's important to see complexity in that broader scheme of things. Some of you will have read the book by Stuart Kauffman, Reinventing the Sacred, where he's very interested in the idea that emergentism is a kind of creativity in nature. The fact that life and brains have arisen reflects a creativity in nature, which to him it's a sort of, has a sacred quality. It's not a personal God, but it's something which is sacred. So complexity, the emergence of complexity is crucial, but it's the ultimate mystery. So how do you explain these things? Well, how those fine-tuning, some people appeal to God. Most, that he chose the constant so that we're here. And most physicists don't like that. Some people say that consciousness itself creates the universe, that you have the Big Bang and it eventually evolves consciousness. And then when the consciousness looks back on the beginning of the universe, as we've been doing this afternoon, it somehow brings the universe into existence. But the other view is that actually the multiverse view, which I talked to you, that there are many universes and the constants are different in the different universes. And we necessarily, it's a selection effect, we necessarily have to be in one of the universes which is going to produce us. It's rather like lottery tickets. If millions of people buy the lottery tickets, it's a bit of a surprise if you win, but someone's got to win. And the multiverse corresponds to the fact that there were many lottery tickets. But whatever view you have of this, and that actually comes down to the question of Einstein. Here's my favourite picture of Einstein in a dressing gown. What really interests me is whether God had any choice in the creation of the world. Because if all the constants were fixed, there's no room for these ideas. But if the constants are contingent, not determined, then the idea is that you can have the multiverse explains these fine-tunings. Whichever interpretation you use, God, consciousness creating the universe or the multiverse, consciousness becomes crucial to our view of physics. And so that's the message I want to give. Now, so you need a new paradigm of physics which incorporates consciousness, a transcendence of space and time, because one of the things that clearly happens is that in your unusual experiences is that you transcend space and time, or at least don't experience it in the normal way. So, and we need a new paradigm which accommodates mental phenomena in some radically new way. And when I say mental experience, I want a model which includes mental experience. I want to be clear that I actually mean all sorts of mental experience. I don't just mean normal consciousness, I mean expanded consciousness. I like this picture here. It's experiences people have, frequencies versus impact. So as you go along, you're going from the mundane to the profound on the x-axis, and you're going from the common to the rare. And I just want to quickly put the sort of experiences some of us have. Gut feelings, deja vu, telepathy, clairvoyance. These are the paranormal phenomena. Premonitions, creative insight, religious epiphany, oceanic feeling, mystical union. So the point is the phenomena become rarer as you go to the top right, but more profound. So we're all very used to the things at the bottom left. So this is, everyone has these, the healers, psychics. These are the people who have them, the genius, the saints. This is the domain of the normal, the paranormal, and the spiritual. Now, I want to model an expansion of physics which is actually going to incorporate all of those, all aspects, including normal mentality. It's hard enough to incorporate normal consciousness into your view of physics. But I think that's really crucial. But of course some of these are controversial. The ones at the bottom left, everybody has them and they can be studied scientifically. These paranormal phenomena, they're quite common, but they're very controversial, even though they can in principle be studied scientifically. Here is David, who's the president of the Parapsychology Association, who does it all the time. Mystical experiences are rare, but normally assumed to be beyond the reach of science, but in some sense they're accepted. Now, so these experiences, they transfer individuals, these are the experiences that transform the world. Whatever your view of spiritual, mystical experiences, you cannot deny that they've transformed the world. What a different place the world would be without Buddha, Christ, etc. To me, the fascinating thing about consciousness and the link with physics is that consciousness, in some sense, involves a specious present. That's to say, we're only aware of things on a certain range of timescales. We're not aware of things which are too short or too long. So, for example, this is a little simulation. This is your conscious time. You can see that going round as a circle. I can make it faster, and it goes round faster. If I make it too fast, you don't see it at all. Okay, time has become space, and that's because the processing time in your brain, above 40 hertz, you can't see it. So time ceases to exist. But now we can slow things down as well. Okay. And now let's slow it down even more. Let's slow it down so it takes 100 years to go around. I can't wait to the end of that, else I'll overshoot my time. But you see, space, it ceases to exist. Time also ceases to exist at the low end. And I think that's really crucial. It's telling you something about consciousness. Consciousness is only defined with respect to a narrow range of times. And I think the crucial thing is that actually one can experience the world in different states of consciousness in which the time scale is either very much expanded or shrunk. And so to me, for example, the evolving hierarchy of consciousness, this is the sort of consciousness which we heard about from Amanda in the brain, which is the speechless present. The shortest time scale is of about 100th of a second. But I think actually there's a level of intelligence in the universe which operates on a longer time scale. I think there is a sense in which the Earth, there is a global consciousness. It's clear that the Earth has a sort of collective memory, intelligence, and consciousness, but it sort of operates on a different time scale. One of my profound memories from that Ecotechnics meeting in '86, Rusty Schweikart gave a talk. Some of you were there. Rusty Schweikart, the astronaut, he did the first spacewalk, and his camera jammed, and for 1 minute he had nothing to do except sit there in space looking at the Earth. And he had a sort of mystical experience, and in that mystical experience he sort of felt that he was one with the Earth, that he was an eye of the Earth. In other words, he became aware of this sort of global consciousness. It always made a profound effect on me. But beyond that, I think there's in some sense a level of galactic consciousness. We are looking for extraterrestrial civilizations. Now, as you know, SETI's just been cancelled because they can't find the money. But if they're there, we'll find them. We now know there are thousands of planets in the galaxy. And personally, I bet you there's other intelligence, other consciousness out there. And, either we're unique, in which case we're very special, or we're part of some much bigger sort of galactic level of consciousness with the galactic internet. And either way, it's really exciting. And maybe even there's some level of cosmic consciousness, but obviously that goes into the level of speculation, as if anything else hadn't. But so anyway, I think that's where I want to end. So I started off with the story of the cosmos, and ended up with the key role of consciousness in the creation of the cosmos. So thank you.